volcanoes influence our climate and how their emissions compare to what we produce. This is by Michael Peterson, Professor of Geology, Auckland University Technology. Conversation. Climate explained. Everyone is going on about reducing our carbon footprint, zero emissions, planting sustainable crops for biodiesel, etc. Is it true what the internet posts say, that a volcano eruption for a few weeks will make all our efforts null and void? The pretext to this question is understandable. The forces of nature are so powerful and operate at such a magnitude that human efforts to influence our planet may seem pointless. If one volcanic eruption could alter our climate to such a degree that our world rapidly becomes an ice house or a hothouse, then perhaps our efforts to mitigate anthropogenic climate change are a waste of time. To answer this question, we need to examine how our atmosphere formed and what geological evidence there is for volcanically induced climate change. We also need to look at recent data comparing volcanic and human greenhouse gas emissions. There's evidence for catastrophic climate change from very large, protracted volcanic eruptions in the geological record. But in more recent times, we have learned that volcanic emissions can lead to shorter-term cooling and longer-term warming. And the killer punch evidence is that human-induced greenhouse gas emissions far exceed those of volcanic activity, particularly since the 1950s. Forging Earth's atmosphere, we can go back to first principles and look at where our atmosphere came from. Earth is 4.56 billion years old. The common consensus is that Earth's atmosphere resulted from three main processes. One, remains of primordial solar nebula gases from the time of earliest planet formation. Two, outgassing of Earth's interior from volcanic and related events. Three, the production of oxygen from photosynthesis. There have also been contributions over time from comets and asteroid collisions. Of these processes, internal planetary degassing is the most important atmosphere-generating process, particularly during the first of 4 eons of Earth's history, the hot Hadean, Hadean. Volcanic eruptions have contributed to this process ever since and provided the bulk of our atmosphere and therefore the climate within our atmosphere. Next is the question of volcanic eruptions and their influence on climate. Earth's climate has changed over geologic time. There's been periods of ice-free, hothouse Earth. Some argue that sea levels were 200 to 400 meters higher than today, and a significant portion of Earth's continents were submerged beneath the sea level. At other times, during a snowball Earth, our planet was covered in ice even at the equator. What contribution have volcanic eruptions made to this variation in climate? As an example of a major influence, some scientists link mass extinctions to major volcanic eruption events. The most famous such association is that of the eruption of volcanoes that produced the Siberian traps, and you can see that concerning a video I just made 2 videos ago on that issue. This is a large region of thick volcanic rock sequences, some 2.5 to 4 million square kilometers in an area in Russia's eastern provinces. Rapid and voluminous volcanic eruptions around 252 million years ago released sufficient quantities of sulfate aerosols and carbon dioxide to trigger short-duration volcanic winters and long-duration climate warming over a period of tens of thousands of years. The Siberian trap eruptions were a causal factor in Earth's largest mass extinction event at the end of the Permian period, when 96% of the Earth's marine species and 70% of terrestrial life ceased to exist. It was an extinction event. Natural climate change over past 100 million years. Geological evidence indicates that natural processes can indeed radically change Earth's climate. Most recently, in the geological terms of the past 100 million years, ocean bottom waters have cooled, sea levels fallen, and ice has advanced. And within this period, there have also been spells of a hotter Earth, most likely caused by natural rapid releases in greenhouse gases. Homo sapiens has evolved during the past few million years, largely during an ice age when up to 2 kilometers thick ice, the sheets covered large areas of the northern continents, and sea levels were over 100 meters lower than today. This period ended 10,000 years ago when our modern interglacial warmer period began. Astronomical cycles that lead to climate variations are well understood. For example, the Milankovitch cycles, which explain variation in Earth's orbit around the Sun, and the periodic nodding and swaying of our Earth's axis. All of the geological and tectonic causes for this general longer-term Earth cooling are less well understood. Hypotheses include contributions from volcanoes and processes linked to the rise of the Himalayas and Tibet from 55 million years ago. Specific volcanic eruptions and climate impacts. Researchers have studied specific volcanic eruptions and climate impacts. Mount Pinatubo of the Philippines produced one of the largest eruptions of recent times in 1991, releasing 20 million tons of sulfur dioxide and ash particles into Earth's stratosphere. These larger eruptions reduced solar radiation reaching the Earth's surface, lowered temperatures in the lower troposphere, and changed atmospheric circulation patterns as well. In the case of Pinatubo, global tropospheric temperatures fell by up to 4 degrees centigrade, but northern hemisphere winters warmed. Volcanoes erupt a mix of gases, including greenhouse gases, aerosols, and gases that can react with other atmospheric constituents. Atmospheric reactions with volcanic gases can rapidly produce substances such as sulfuric acid and related sulfates that act as aerosols, cooling the atmosphere. Long-term additions of carbon dioxide have warming impacts. Large-scale volcanic eruptions, whose ash clouds reach stratospheric levels, have the biggest climactic impacts. The larger and more prolonged the eruption period, the larger the impacts, of course. These types of eruptions are thought to have been a partial cause for the Little Ice Age period, a global cooling event of about 0.5 degrees centigrade that lasted from the 15th to the late 19th century. Supervolcanoes such as Yellowstone in the US, Toba in Indonesia, Taupo in New Zealand, these are all supervolcanoes, and you'll see that yesterday I made a video on those supervolcanoes, those 3 supervolcanoes specifically. You'll find it Yellowstone, Toba, and Taupo supervolcanoes and past super eruptions, their recent activity. That's about 20 videos back. And theoretically, they can produce very large volume eruptions that have significant climate impacts, especially the one in Toba. That was something. But there is uncertainty over how long these eruption influences the climate. Perhaps the strongest evidence for answering whether our human emissions or volcanoes have a stronger influence on climate lies in the scale of greenhouse gas production. Since 2015, global anthropogenic carbon dioxide emissions have been around 35 to 37 billion tons per year. Annual volcanic CO2 emissions are around 200 million tons. In 2018, anthropogenic CO2 emissions were 185 times higher than volcanic emissions. This is an astounding statistic, and one of the factors persuading some geologists and natural scientists to propose a new geological epoch called the Anthropocene, in recognition that humans are exceeding the impacts of many natural global processes, particularly since the 1950s. There's evidence that volcanoes have strongly influenced climate on geological timescales, but since lately, 1950 in particular, it is the Homo sapiens that have had by far the largest impact on climate, so let's not give up on our CO2 emission reduction aspirations. Volcanoes may not save the day. And this is on the Conversation Creative Commons. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.